Alright, let's get started here today. So, just wanted to cover two, they're not new concepts, but they are concepts that are kind of important to a couple assignments going forward. So we're going to talk about some array operations. So let's say you have an array of integers and you want to do something like get the sum of those integers, get the minimum, get the maximum of those integers. I could do it with like decimal numbers too, but we're going to use integers in this example. So we'll talk about that, and then we'll talk about reading an entire line from the user. And then we'll talk about assignment 6, assignment 7, and then we'll also have an in-class assignment at the very end. Alright, so I'm just going to go through, I'm going to just show you some code to do the sum, min, max. It's important to know, so let's do that. Array ops.c. So let's do this. We'll have our, we'll make this function called fill sequential, which will fill the array that we pass in with numbers from 0 up until the length of the array. Pass in our array, pass in our length, and then what we'll do is we'll say got our index. This should all be review stuff. I equals 0, I is less than len, increment I, and then we say array at position I equals I. So let's say we have an array, it's 10 big, so we'll say fill seq array, put 10 integers in it, and then let's also make one to print things out quick. So let's take this down, and what we'll do is instead of putting I there, what we will do is print it out. And we'll say like that, so we'll print the position on the left and the value on the right, so we'll print I, and then array at position I. Go ahead and change this to print R. So we'll fill it, we'll print it, and return 0 at the end. Alright, I left a parenthesis off my printf right here. Alright, there we go, we got an array. So let's write some functions that will do sum, min, max. So I think we've probably done sum before, but let's just go ahead and do it again. So there's two different ways we could approach doing these functions. One way is we could say void and it wouldn't return anything, it would just print off the sum, the min, the max, or we could actually return the sum, the min, or max from our function. So for right now I'm just going to not return anything. So we'll say sum array, pass in our array, pass in our size or length, same setup as before. The only thing is now we also have a sum variable. We'll set that equal to 0. So say for I equals 0, I is less than len, increment I, and we'll just say sum plus equals I, or not, sorry, array at position I, and then printf sum is sum. Now we'll just print out sum. So when we call that function, first of all, what will happen is, of course, we'll fill it, we'll print it out, and then we will print the sum. So we'll say sum, say sum r, yes. Sum r, pass in the array, pass in the length, one more time, and there we go, we get our sum. So that one's pretty easy. We've talked about that one before, I think. The ones we haven't talked about, though, are minimum, maximum, and then I think we'll do average too. That's one we haven't done. So let's do, what I'm going to do is I'm just going to copy this whole thing down and it'll speed things up a little bit. So we need a minimum, so we'll min array. Alright, so when we're doing this, we'll still need this, a second variable here. But what we will do is we'll say r at position 0 is the minimum. And then what we're going to do is instead of starting at position 0, we are going to start at position 1. So the way this loop would, or the way this function is going to work is what we're going to do is we're going to assume the first number is the minimum. And then going on from that, if we find a number inside the list which is smaller than that number, we're going to replace the minimum with that number. So what we would do is we would say if r at position I is greater than min, clean this up a little bit here. So if array at position I is greater than, or sorry, less than minimum, what am I thinking? Less than minimum, then we are going to set min equal to r at position I. Alright, and we're going to go through every single element in our list, and if any of those elements are less, so if any element in our list is less than our current minimum, we're going to set the minimum to that number. So let's do this, min is that. So we will say min r, r, and 10. Compile it. I changed my variable name, but I didn't change it up there, so if I go back there, you can see that my variable name right here is still sum. That should be min now that I changed it. And there we go. And we can see that the minimum was in fact 0. In this case, what happened, since our array started at 0, at the 0th position was 0, what happened was we set 0 equal to min, and then for every other number it didn't matter because none of the other numbers were greater than. So just as another example, let's take this and let's, instead of fill sequential, we'll say fill sequential descending. So just so we can get a better example of what's going on. So what we'll do is instead of starting I at 0, we will start it at length. We will say I is greater than or equal to 0. And increment I. And then what we'll do is go down here and change our fill sequential to fill sequential descending. Did I not save that? What did I do? Oh, I have a DES, no C here. I need a C here to match the function names. That's what I'm doing. Alright. Oh, that's funny. So I'm filling it from the end to the end of the front, but I'm still using the same index variable. So I'm starting at position 9, but I'm setting it to 9, and then 8 and 8. I'm just filling it in the reverse order. What I also need to do is have another index variable, start that at 0. Increment that, and that will work now. There we go. So now we're filling it in reverse order. So we can see I did end up starting at 10, so our minimum is now 1. So every single time we go through an element here, that if statement's going to be true, and we're going to replace minimum with that number. So very similar approach going on. We're going to continue on to do maximum, very similar approach. Really the only thing we have to change is that one comparison, that one less than right here, change that to be greater than. And that's really the only change we'll need. Of course, change our names here. I'll do that just so it's more understandable. So max, 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 and finally max. All right. Again, all we have to do to change to that our minimum function to our maximum function is change that less than to a greater than. So just copy that down, and we'll run max array. See what that gives us. And we can see the maximum is 10. So same thing happened here. Happened before is we found the first number, and then none of the other numbers we saw in the list were greater than, so we stopped looking for any numbers. Alright, so finally what we're going to do is do average. So average takes a little bit more work, but one of the things that we can do is we can actually leverage the sum array function that we already have to do most of the work. So we'll say average array, pass in our array, pass in our length. So we could either rewrite all of this stuff again, or since we have that sum function already, since we need sum for average anyway, what we can just say is sum equals sum array, pass in our array, pass in our length. And then what we can say is, we'll say double average, because we may have a decimal remainder. What we'll say is sum divided by length. And remember, since our sum and our length are both integer values, we will need to cast one of them to the double type so that we get a good conversion. So we'll need to say double on one side. Remember that if you don't say double like this when you're dividing an integer by an integer, it's going to drop the decimal component regardless. So just remember, if you're dividing two integers, you do have to cast one of them to double. Remember, we haven't talked about this in a while, but this is a typed cast. So it converts one of our variables to be a different type. So remember, another way we could do this, depending on how you wanted to do it, is say something like sum times 1.0. That would also successfully convert it to a decimal number. But typically the way you would see it done is like this with double. And then finally we will go ahead and print it out. Give it 2 decimal places, that should be good. And then we will print average. Go down to the bottom. And that's our problem. So you noticed here when I decided to do this, I just printed inside it. So what I'll do is right now, I'll do it both ways. I'll print it and I'll return it. Typically you'd want to choose which way you did, but we'll just right now to fix it, I'll just return it as well as printing it. Remember that down here when we're calling that sum, we can just ignore that return value if we so choose. That's completely allowed. Alright, and we can see that the average is 5.5, and that makes sense, I think. Yeah, that makes sense. So that's how you would do all those functions. So talked about sum, talked about average, talked about min, talked about max, and then we had our review down here of fill sequential. We talked about this one before too, the descending, and then print array. So any questions about array operations, doing operations over arrays and things like that? All right, so next thing. Wrong way. Next thing we're going to talk about is that reading a line from the user. So we had talked about before with scanf, reading into a character array. So remember we could say something like this. So we've got our character array. I'll call it str. Give it 20 positions, and then we'll scanf into it, so we'll read into it. And then print it out. It's pretty straightforward. Say ASDF, and we get ASDF printed back out. I'll add this new line on here just so we know what's going on. But one thing we haven't talked about yet is that when we're doing a scanf, it actually only reads in one single word. So if I type 2 different words there, it only reads in that one single ASDF. All right. So one of the things we can actually do is we can read in an entire line. So we can use the gets function to read all the way until a new line is encountered. So instead of just reading in one word, let's say we wanted to read in the entire line. So we want to read in all of this input instead of just that one word. What we could do is say, comment that out, and then we're going to say gets str. Yeah, that's fine. Well, it's not fine, but it works. ASDF, ASDF. So we can see both of those were read in successfully. But there's a lot of warnings here, and we're going to talk about why there's all those warnings. So again, the difference between a scanf and a gets, or gets as some people would say, is that it reads all the way until the new line. So one thing that we have to keep in mind, we talked about scanf before, but now with gets, we have to think about this too. So, sorry, that the should be they. So the problem with scanf and gets are that they allow you to read more characters than the size of your buffer, your character array, your string. So when you do that, if you overwrite other components, or if you allow them to read in unlimited numbers of characters, what will happen is you can start to override other parts of your program. So we looked at that before when I just typed a bunch of A's into scanf, and that started to override other components of the program, and that resulted in a segmentation fault. So let's talk about what we can do to fix that. I don't think I talked about that before. So one thing we can do to secure scanf is we can specify the total number of characters we want scanf to read in. So this first example is unsafe because it allows any number of characters to be read into str, but we can use this syntax, the safe syntax, by specifying .10 or the number of characters we want to be read in. And then the exact same syntax, except we say .10 or .20 or however many characters we want to be read in. So let's test this out. Let's try and only allow 4 characters to be read in. So we put a .4 between that percent and that s. Or do I just do 4? I might just do 4. I thought I did point. Yeah, I guess I don't do point. We just do the number. So now when I type ASDF, ASDF, what should happen is we're only allowed to read in 4 characters. So I should update this now. Sorry about that. So we only specify the number we need, no point. So let's say we had that array of size 20. What we want to do is only allow 19 characters to be read in. So we want to say 19. So we need to say 1 less than the total length because there needs to be that 1 space for the null terminator. So we read in 19 total characters, and then scanf will automatically append that null terminator. Again, I messed it up. I put the point there. Don't need that. Just need the number of characters we want in, right in between the percent and the s. So that's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So what's going to happen is we should drop that last F because it will only read in 19 characters if I know what's going on. And I don't know what's going on. 1, 2, 3. Yeah, that's only 16. Okay, I'm just counting wrong. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now we should cut off that last G if I again know what's going on. Yep, so we read in 19 characters. We saved room for that null terminator, that imaginary null terminator right there. So that's how we would secure scanf, by specifying the number of characters that we want read in between the percent and the S. So let's say we wanted to read in the entire line. So we need to look at a different function called fgets. So fgets is safe because it provides it allows us to restrict the number of characters that are going to be read into our buffer. So fgets is like getS, but it stops reading once n characters have been read, or it also stops when a new line has been reached. So it'll either read up until the new line, or up until you hit the limit on the number of characters you can read into your buffer. So let's look at this. So let's take this down a little bit here. Let's give us 5, and then we'll say getS like before, and str. So remember, this would allow us to do something like this. Sorry, I need to say getS and not oh goodness, getS, there we go. That allows us to type in unlimited number of characters. It's going to crash our program. So changing to fgets, when you say fgets, first parameter is where we want those characters to be stored. Second parameter is how many characters we want to read in. And the third parameter is where we want to read those characters in from. So we'll talk about this in a little bit, but we want to read them from standard in. And standard in is where functions like gets and where scanf read in from by default. But fgets requires us to actually tell where we want to read in from. And the syntax is a little bit different, so we specify the total number instead of just the number. So that number will include the null terminator at the end. So we would use the same number here as that we would use for our length of our string. So we say ASDF, and we get ASDF. So that's pretty straightforward, I think. But the one thing to note is the difference between gets and between fgets is, let's say I type A and then I hit enter. What's going to actually happen is we're going to also read in that /n. So when we didn't read it in when I typed ASDF, because we already had 5 characters, we reached the character limit before we read in the new line. But if I was to only type 1 character, we'd read in A, we'd read in new line, and then so our array would be A, new line, and then null terminator. And then when we went to print that, we'd also print that new line. So getS doesn't read that new line. So one of the things we'll need to do is deal with that, because normally when we're printing stuff out, we would want that new line stripped off. So before we go on though, talking about that std in a little bit more. So in C, files and other devices are described using a file type. So later on you'd see something like this. You'd see file, my file, and things along those lines. So that would describe a file. We won't talk about that now. But by default, you have the files available to you, stdin, stdout, and stdair. So stdin is all of the things you type in. stdout is the stuff that goes out to the terminal. And then stdair also goes out to the terminal, but it's a little bit different. We won't really talk about it now. So files are covered more in 250, but all you need to know now is that if you want to read a line, you need to use fgets, you need to use standard in. So again, with fgets, we do have that problem with that new line being appended, So what we need to do is what we can do is just remember this, that when printf encounters a /0, it will stop printing. So what we can do is just prematurely terminate that string by putting a /0 at the end. So what we will do is this. So we're going to find that character, that /0, or sorry, we're not going to do that. We're going to find that /n and we're going to replace it with a /0. So pretty simple function. We're going to write a generalized function right now that can be applied to a couple different scenarios. But you could write one that all it does was replace all the new lines with /0s. So what we're going to do is call it char replace. We'll pass in our source string and we'll pass in our target. So we're passing in an array of characters, a string, and then we're also passing in a single character, which is what we're going to search for. So what we'll need to do is loop through all of the characters. Sorry, we are also going to need our length. Let's do it a little bit differently. What we're going to do is, remember, we have that string length function available to us. So we can say strlen, and that will give us the length of the string. So again, that's something we can do with strings that we can't do it with arrays. If we had an array of integers, we would have to pass in that length, but since we have that null terminator at the end of our string, we can calculate how long that string is. So say I is less than len, increment I, and then we'll say if source at position I equals target, and then I forgot we'll also need this parameter. We'll just say replacement. So we'll pass in the string we're working on, the character we're targeting, and also what we're trying to replace. So if one of our characters in our string matches the target, what we're going to do is replace that position with the value specified in replacement. And then after we've done one replacement, we could return immediately. We wouldn't have to do all of the rest of the comparisons if we just wanted to do one operation. If we wanted to replace one new line with a /0, we could return immediately. But since we want this function to be a little bit more generalized, we might want to use it in some other circumstances. What I'll allow it to do is loop through all of the characters. So let's go back down here. Let's expand this out a little bit so we can always have enough room for that new line. Well, not always, but for our examples. And then what we'll say is char replace, pass in our source string, pass in what character we're looking for, and then pass in what character we want to replace it with. And remember, when we're using those functions, that strlen, what we need to do is include string.h. What did I do? I said str and not src. And did it again. src, src. So we'll say ASDF, and now with our character replacement function, it replaced that new line that would have been there. So remember, let's do this twice. We'll print it out twice. We'll print it before and after. So that's before. So all of this right here is printed before, but remember that new line sitting there is replaced with this null terminator which stops the string right there and only prints that much. So that's the difference. Now that we have the generalized function, let's go back and let's do a little bit more. Let's go ahead and replace all of our A's with Z's. HDF, ZSDF. So another example of why you want to write your functions to be more generalized. You could write a function that would just replace those new lines with /zeros, those null terminators. But writing a more generalized function allows you to immediately solve other problems because you don't have to reduplicate that code. So that's a cool little function too. Definitely take note of that character replace function. Definitely a really good one to have. So that was our character replacement function. Now let's talk about assignments. So any questions, anything you want me to talk about that we've covered today? All right then. So let me just move this over here. So assignment 6. I'll go into detail and cover it first. My write-up there was a little bit better. So for assignment 6, what you're going to do is simulating a deck of cards. So you'll be shuffling those cards, sort of dealing them out one at a time. But basically, here's what you're going to do. You're going to create an array of 52 integers. So there'll be one position in that array for each card value. So fill the array with unique random numbers. We'll talk about how we would do unique random numbers today. That's important. And then each number will represent a different card. All right, and then after the deck has been shuffled, you should print a card every time the user hits enter. So every time the user hits enter, you would print a card. So let's look at the example here really quick. The program itself isn't very difficult, I don't think. So we can go over here to test assignment 5, I believe. Are we on 6? Yeah, there we go. Assign 6. So before this happens right here, you'll establish your array, you will shuffle it up, and then every time the user hits enter, you're going to print out a card. So 7 of diamonds, 8 of clubs, queen of spades, so on and so forth. So what you'll need to do is you'll need to have an index variable to keep track of where you are at in the deck. So when you first shuffle the deck, generate your unique random numbers, and then after you have that, you'll start at 0. Once you get one card, you go to position 1. Once you get another card, you go to position 2, so on and so forth all the way down the line. So the other thing you have to keep track of is once you reach the deck, so once your index is greater than 51, what you'll need to do is reshuffle the deck and reset the index to 0. So when that happens, you also want to notify the user, so you'll say at the end of the deck, reshuffling. And that's pretty much that. So the trickiest part about all of this is determining the suit and the rank from those numbers. So again, that array that we're talking about has unique random numbers 0 through 51. So one of the ways that we can represent it, one of the ways I like representing it, is like this. So we have this card representation, mod, and divide. So what we do is we assign every single card a value. So one thing to note, I couldn't start my numbering thing at 0, but these should start at 0 for this to work correctly. So we'd start numbering cards at 0, number an entire suit. So it would be 0 through 12, and then 13 through 25, 26 through 38, 39 through 51. So each suit has a certain range of numbers. So in order to get which suit we have, we would take the number of the card and then divide it by 13. Remember when we're doing integer division, we're going to drop that remainder off. So let's say we had the jack of clubs right here, which has a value of 10. So we would take 10, divide it by 13, and we'd get 0. And that would indicate that we are currently working with a club. in order to get the value, we would take that card and mod it by 13. So remember what this does is it gets the remainder of that division operation. So if we take 11 or 10 for this jack of clubs and we divide it by 13, we're going to be left with a remainder of 11, indicating that that is of 10, indicating that is a jack. So the same thing is going to apply for every other value. So even any jack that we take and mod it by 13, we're always going to get 10 as a remainder of our division operation, and that's the way the rest of the cards are going to work as well. So yeah, it takes a little bit of work to get used to, and we'll probably spend some time on Thursday talking about it more, maybe if you have questions. But definitely think about how you represent cards like this by dividing it to get the suit and then modding it to get the rank. I duplicated this. Anyway, so yeah, examples right here at DIST assignment 6. So due a week from today at midnight. So it's going to be worth 10 points. And then 5 bonus points if you print hearts and diamonds in red. So you can see here from my example, I'm printing it in red. Not going to tell you how to do that, but if you figure out how to do it, then I'll give you 5 bonus points. So that's that, and it will continue printing forever, no matter what the user types in, as long as it hits enter. So I could type all of this in, and then as soon as I hit enter, it will give me another card. So one of the functions we talked about earlier was getting input, filtering out everything except for a certain value. So that's one of those functions you'll need. So then Control-C to exit. So that's our first assignment. Any questions about that? All right. So our second assignment, oh shoot, I need to cover the unique random numbers. This is not good. I copied the slide, and it was for a different assignment. So I guess I'll just go ahead and do an example. So what we'll do is we'll have unique.c, and what we'll do is have this. We will write an isUnique function. So bool is unique. So we'll pass, what we'll need to do to set that up is have a usage array and a value. And we need to include bool, or std bool, to allow us to use that bool there. So what we'll do is we'll have a usage array, usage. Let's give that 50 positions, and then we need to make sure to zero that out to make sure all of our values are 0. So essentially what we're going to do is as soon as we see a number, let's say we have a val 10. As soon as we see this val 10 once, what we're going to do is set a position in this usage array to 1 or true. So in order to do this a little bit better, we can do this too. We'll make this a bool. We'll make it bool usage, and we'll set everything to false. And we'll change things around a little bit here. So what we would want to do is call our isUnique val, and that would test to see if the value that we have right here is unique. So what we'll do is we'll say usage, oh, shoot, that's false, that should be bool. What we will say is usage at position val, when you say have an if statement, sorry, if usage at position val equals true. So if we've seen that position, we will return false. Otherwise, we will set usage at val equal to true and return true. So with this array of booleans, remember a boolean is just a 0 or a 1. False or true is just 1, 0 is just false, but this kind of helps us out a little bit. What we will do is say the value, we're going to look at that position. So for 50 values, so the only values we can tell if they are unique are 0 through 49, but for 0 through 49, if we pass that value into that function, let's say we pass in 10 here, so we get that 10. By default, all of the usage positions are false. So when we pass in that 10, we're going to go up here. So we're going to say usage at position, we're going to say if usage at position 10 is true, which it isn't. When we start out, when we call this function for the first time, it's going to return false because none of our positions are true. We set all of our positions to false when we start out. So since that condition is not true, we're going to execute this. So we're going to set usage at that position equal to true. So we have used that position once, and then we're going to return true because the first time we called it, it was available. So looking at this, it might not make sense right now. The logic is a little bit funky, I'll admit that. So this first time we call it, we should get a 1 right here, and the second time we call it, we should get a 0 right here because it has been used already. I need to pass in my usage array, it looks like. I need to pass in usage, I need to pass in the value. And there we go. First usage, return true. So the first time we tested it, if it was unique, it would return true, but it set its position inside of usage to true after that. And then next time we come around, next time we call it, that position was true, so we return false because it was not unique. Now, ideally what we would do is say something more like this, is unique and set, because that describes our operations a little bit better. We're testing if it's unique and setting the value. So we need to change our function names here. And there we go. And we could do this for any other value as well. So any value 0 through 49, we could see if it's unique by utilizing this method. But if we wanted to do values bigger than that, we of course have to increase the size of our array. So that's our isUnique example. So any questions about that? I know the logic is a little weird because we're checking if it's true and then returning false, and then checking if it's false and returning true, and setting true and false. And it does get confusing, I would say that. But anything that doesn't really make sense you want me to talk more about here? Yes, so the way you generate, that's another thing you'll have to do is you generate, so basically what you do is you are going to loop through your array that represents your deck, generate a random number between 0 and 51 inclusive, and then if that number exists in usage, you're going to have to generate another one and keep generating random numbers over and over and over again until you find a unique random number. So that's the whole point of this unique. In order to do this, the setup is very similar to this, It's just your val should be the result of your random number generation. And if your random number generator, again, isn't unique, you'll have to generate another one. So that's that for the random numbers and assignment 6, I believe. So you noticed, you can read the PowerPoint if you want to. So assignment 7, also in D2L, also due a week from today. So for this one, we're working with strings. So what I want you to do is re-implement several of these string functions we talked about. So I want you to do your own implementations of string length, string copy, string compare, string cat, string chr, which is search. So, and then these is alpha, is digit, is space functions. So I think I'll just let you read through that. All of these functions, we've talked about them before in class. We've used the system versions, but I want you to go through and create your own functions. So you can't say strlen for your function because it's already defined by the system, but you can say my and then strlen because that's not defined. So rewrite all those functions that we've talked about before working with strings. Yeah. So that's also worth 10 points. It's also due a week from today. And then there's a couple other bonus point opportunities for that. So write stir ncopy and stir ncat, which take a third parameter, which is the size of the destination. So remember, we had two different functions. We had two different functions when we're working with stir copy and stir cat. We have stir copy and we have stir ncopy. So stir ncopy, the difference is it copies up to number of characters. So we provide that third parameter to limit the number of characters that are copied, so that we're not overfilling our buffer. So if you'd like 5 bonus points, you need to write a my stir ncopy function and a my stir ncat function. Again, taking that third parameter, which is the size of the destination. Which the basic functionality difference between those two is they stop copying characters when the size limit is reached. So in order for you to get points for that, you still need to have the original functions. These are just functions on top of those functions. And then the final bonus point opportunity is write a char digit to integer function, which converts a character digit to an integer. So you're going to return the integer value of that character digit value. So remember, this is not the same as that. We talked about a way that you convert a character 0 to an integer 0. You'll have to think about that a little bit. But if you write a function to do that, so you'd take a single parameter character, you'd return an integer value. That will also be worth 5 bonus points. The other thing you have to take into consideration is returning -1 if the character provided is not a digit. So if I have this function right here, and I pass in a, that should return -1. So your return value should be -1. Otherwise, if I pass in character 0, you should return 0. If I pass in character 1, you should return 1, and so on and so forth. So yeah, that's that. Any questions about assignment 7? All right then, so I don't know if we'll have enough time for the rest of the class. It's not a very difficult assignment, I don't think. But I want you to create an array that can hold 10 integers, fill each slot with a random value, 1 to 50, display those values on the screen, then prompt the user for an integer, search through the array and count the number of times the item is found, and then submit to day 23. So I should make this a little bit bigger here. Stupid presenter. So, look like this. A little closer up. So you print the array that you generated, the value to search for, and then print out the number of times it was found. So ideally do it in the function, but it's up to you. And you don't have to loop, you don't have to do it multiple times. You can just do it one time, that's fine. So yeah, that's the in-class assignment. I'll be around to talk about anything else if you want to as well. So that's all I have. Huh? No, not right now. Because all you're really doing is re-implementing the functions that the system already has. And we've talked about almost all of those functions in class, so I don't have an example right now. What the thing about that one is I don't really have any set expectations. There's no real outcome of the program. It just re-implements those functions. So one additional thing I'd like you to do is demonstrate all of those functions being used inside main. I didn't write it in the assignment, but I thought that was kind of, I'll go rewrite it now. That I want you to demonstrate all of the functions that you're using in main.